Hello and welcome. I'm Thomas and this is day 16 of 100 Days of Code in IoT Challenge. Today, I'm going to show you how to use this 7-segment 8-digit display. This model is MAX7219. And I'm going to use it with ESP8266, the default microcontroller I'm using during this challenge. And we display some information, mainly digits, some letters, just some letters because not all of them are supported. As this type of screen, it is limited, right, to 7 segments. And optionally, at the end, I'm going to use well-known DHT11 temperature and humidity sensor that I used in the previous videos and make this screen displaying temperature and humidity. Okay. Let's move to the breadboard view so I can show you all the parts and components that I'm going to use today and describe all the steps. So today we have a small breadboard with ESP8266 already attached, a MAX7219 7-segment 8 digits display, a bunch of wires. For the simplest circuits, you just need 5 of those. I also have this power supply module. It is actually nice to have because the display module input voltage is 5 volts. It is going to work with 3.3, but it is not very visible. The digits are not really visible with 3.3. The base is actually 5, so I'm going to show you how to power it with 5 volts. And also for this one, essentially what I'm going to need is this AC adapter. Alternatively, you can use the USB module to power the displays. It can give you 5 volts. Optionally, I have the temperature sensor, DHT11 from the previous videos. And I also have a second display, so 2 of them in total. And if I have some time, I'm gonna show you how to connect 2 of them using something called a daisy chaining. So basically you connect this one to that one in here by connecting these pins. However, this configuration is gonna need capacitors to stabilize the current. Capacitors I'm gonna use is 2 of those which are rated for 100 microfarads and 50 volts. And I also have this one, it's 104, rated for 100 nanofarads. And this one, which is rated for 22 picofarads, but essentially you could just use 2 of those. And the last bit is micro USB to the standard USB cable. And now let me just quickly go through the to-do list. So today we're gonna start from the simplest circuit, just ESP8266 and the display module, power supplied from ESP. Then the coding part, so I'm going to show you how to program the device to display values on the screen. The next step is going to be supplying 5 volts to MAX7219, however still keeping the 3.3 power supply from USB to the microcontroller. And also, apart from the standard power supply, I'm going to show you how to connect the USB module and supply power from there. And then, however, that's going to happen tomorrow because we're not going to have that much time today. I'm going to install the core library that I've built yesterday, connect DHT11 temperature sensor, and using those tools and components, I'm going to show you how to display things like time, temperature, or humidity on the MAX7219 screen. And finally, I'm going to connect multiple displays It's just gonna be 2, but essentially there's not gonna be anything stopping us from connecting another one. And that concludes our to-do list. Okay, so let's move to the first step. So I'm gonna take the breadboard with ESP already attached and the display module. On the display module, what we have to do is to locate VCC and ground, and also make sure the next pin below ground is DIN, not D out. D out is incorrect one, it's on the other side. So D in, right? But first of all, we're gonna take VCC and ground and connect these 2 wires. The yellow one is gonna go to VCC, the green one is gonna go to the ground. Okay. And the other side of the wires, they're gonna go to 3v3, yellow one to 3v3, so we will have VCC connected to 3v3 to supply power, and ground to the ground. Okay. Next, I'm gonna take the gray wire and connect it to D in on the display. Okay. And the other end is gonna go to D6 on the board. Orange wire is going to CS pin on the display, the other end D7 on the board. And the last one is this dark purple, which is gonna go to the CLK on the display, and the other end is going to D5. It is actually important when you connect these wires. So yeah, let me show you this table. For example, D8 is not really recommended to use, because if it's pulled high there, you will have problems with the boot. So it's better to not use that pin for the display module. Okay, so yeah, that's it for assembling the simple circuit. Let's move to the code. Okay, so I've got Visual Studio Code opened. Not really on any particular project, because I'm going to create a new one. So I'm gonna do, first of all, I'm gonna go to PlatformIO open. So this icon, open, and then new project. And I'm going to call this project 7 segment, maybe like this, 7 segment display. The board is gonna be Node MCU 10, framework Arduino, use default location. Finish. Okay, so I've got the project created. I need to specify monitor speed. That's gonna be 115,200. This is important because in the main.cpp, in the setup, I'm going to set up the serial with this value, and I'm going to copy it to make sure it is that value. Okay, now let me just quickly do a 1 second delay. Okay, and now to use the MAX7219 display module, the easiest way, without going into datasheet, the very low level stuff with the SPI interface, what we could do instead is to go to, again, to PlatformIO, open PlatformIO, then go to libraries, and I'm gonna type 7219, MAX7219, and then I'm gonna locate, by pressing the more button, because it's not on the top, The library I'm interested in is called LED controller. It is a bit better than the LED control one. So here I'm gonna just press add to project, and then from the menu here select my 7-segment display project, then add, and that is done. I can close the PlatformIO home window now. Okay, so that is done. I'm gonna have to include it now. So that's gonna be include LED controller. And what else I need to do is to create an instance of this one. To create an instance, I'm simply gonna type in LED controller, and then I'm just gonna call it LED controller. I mean, the variable, this is the instance, is going to be stored. And now I'm gonna have to provide pins. And for that, let me just copy paste the list of constants I have created for myself before. And what we want to make sure about is to have those pins reflecting what I have connected on the board, right? And you probably remember the clock pin was D5. The data pin is D6, and CS pin is D7, right? I'm not using D8. So now what I could do is actually order them by pin. The number of segments is basically the number of displays. At the moment, it's just one display. So I'm gonna keep it 1. And then here, what I have to provide is, first of all, that's gonna be the data pin. This is the first value. The second one is going to be the clock pin. You will see this in a second. Actually, you see it already right here in the hinting, right? The first one is data pin, then we have clock pin, and then there's gonna be a CS pin. And the last one is going to be the number of segments. Okay, so that is enough for the constructor here. And now, to start the LED controller up, I'm gonna call a few methods, right? The first one is going to be activate all segments. So that's just gonna activate the first display, the display, you know, all the segments, but we have just one, so it's gonna activate the first one. Then this one is required to just start, but also what I'm gonna do is to set intensity to 15, which is the maximum value. It is needed because we don't provide 5 volts but 3.3. So to make those digits clear, it's better to use the highest intensity. And then as the last one is going to be clear matrix. And clear matrix is simply clearing the display. There's not gonna be anything displayed there. Okay, I'm gonna do another delay for 1 second, the blocking one, and let's display something there, right? In order to display something quickly without any complications, but yeah, basically it is only limited to digits and characters. We have 2 methods. One is set digit that allows us to display a single digit, or set char, right? That allows us to display a single character, but it also includes digits. So I usually use just set char for everything. That takes a few parameters. The first one is the segment number. So that's the display number. I'm gonna put 0 because 0 is the number of the first one. Then the second one is the digit. So digit is the position on the display itself. The 0 is the one which is the last one on the right, right? So this is 0 position, and this is 7 position, right? So it starts from 0 and goes up to 7, right? From the right to left on the display. So what I'm gonna do is to display let's say this is gonna be a char, but that's gonna be a digit essentially. Let's display 1 on the position 0. So the one on the right hand side, the first on the right hand side. There is also the last parameter, which is the decimal point. Also, I'm not sure if this is gonna be visible, but you can see there are these small dots in here. And those small dots can also be light up by specifying true here, but I'm gonna specify false, at least for this one, right? With the set char, you can display only 1 character. However, if you want to display more, which is what I want to do, is to just repeat yourself and set, you know, another char and another char, but on different positions, right? Because one, you set the character or the digit on a certain position, is gonna stay there until you change that, right? And changing that can be done by clearing the matrix or clearing the segment. There is also a method to clear the segment. So essentially what I'm doing here is displaying something like that. Let me show you. So that's gonna be 32.1, right? So the one, again, that starts from the right to left. So we have 1 on the right, no decimal point, right? Just 1. Then we have 2 with the decimal point, and then we have 3. That's position 2, which is the third position from the right to left, right? And that goes on up to 7. The 7 is the one, the digit or character on the left. Okay, so that's what I'm gonna do. And yeah, essentially this is it. Let's just display 1, 2, 3 and see how it looks like. So let me deploy this. Make sure the USB is connected. In my case, it's not really connected, so I'm gonna do it now. Okay, connected, and I'm going to compile and deploy. Okay, that's deployed. And as you can see, it is displaying 32.1. Let me just dim the light a little bit, so it's gonna be visible, right? So we've got 32.1. Okay, it is actually quite visible, to be honest, if I'm looking at that, even though this is powered with the 3.3 volts. However, I'm just thinking, if I change that value and do like 8765 and so on, and just light up all the positions, then this is probably gonna be a little bit dimmed. Let me try though. Okay, so to not to have to repeat myself, I'm gonna just write a simple for loop. So we'll have unsigned in 0, and that's gonna go up to 7, I++, and what I'm gonna display, maybe this time I'm gonna do other way around. So we do 1, 2, 3, 4, 5, 6, 7, and 8. So in the loop, I'm just gonna run a set char, and that is gonna be the segment number 0. But we're going to start from the last one, right? So the 1 is gonna be the last one. So hang on, let me just quickly figure this out. So we want to start from, oh yeah, that should be actually fine. So that should be fine, right? Because if we start from the position 0, if we're starting from the position 0, what we need to do is to subtract, right, from Do we? Oh, hang on. Yeah, we need to subtract from I, right? So that's gonna be 8 minus I always, right? So if I is 0, we're gonna have 8 at the position 0, which is on the right side, right? And then it's gonna go up to 7. So we have 1 on the left, right? So that should do. And I can remove this one. However, because that needs char, I think what I have to do is to cast it to char just to make sure. I don't think it is required, but just to, sorry, it's all the way around actually. So I'm gonna do just that, right? Char. Let me see if it compiles first. If I didn't do anything wrong, yeah, that's fine. Okay, and now I'm gonna deploy. Okay, so as you can see, this is working. And to be honest, let me just decrease the light. To be honest, this is all fine. In my opinion, this is all fine. It just shows you all the values. So if all of the positions are lighten up, right? So we have all of those taken, all the numbers displayed, and they okay. We don't see any flickering or anything. I can easily assume that 5 volts is not really required, right? But still, especially if you want to connect more displays, you may need 5 volts an external source of power or voltage supply. Okay, so now what we're gonna do is to modify the circuit and supply 5 volts to the module, right? So let me start from disconnecting the USB, and then that's gonna be pretty straightforward, because what I have to do is to disconnect these 2 wires, that is VCC and ground here. Not sure how visible it is. Yeah, you probably see. So the green one and the yellow one, right? And that VCC and ground are gonna be connected to those power grids, right? To those power rails on the breadboard. It is important to connect VCC to plus, somewhere here maybe, and the ground to minus, right? So in our case, the yellow is the plus, which is the VCC, and the green is minus, which is ground, right? It is connected to ground. Okay, maybe actually it is, I need to just move it, let's move it somewhere there, because on this side I'm gonna connect a power supply module, which is the next step. So here, a power supply. Okay, maybe there, because I'm thinking about connecting the temperature sensor at some point. So the power supply is going there. And what is also required is to connect the grounds together. So we have common grounds. So what is important is to locate a ground on the board. So there is one here. And I'm gonna connect the black wire. And that black wire is gonna go to minus here, right? Because we're gonna power the board with the USB, that's 3.3. And we're gonna power the display module with 5 volts, that's 5 volts, right? But for the display to work, we need to have a common ground. So I have connected the ground of ESP8266 to the ground of the power supply module on the 5 volts. Okay, so now what I'm gonna do is to connect the AC adapter, okay, then the USB here to supply power. Okay, so it started actually, I'm not sure if it's visible, it is flickering at the moment because we don't have any power supplied to the display module apart from the information sent by those digital pins. So what I'm gonna do is to switch this one on. Okay, switched it on. Now it's cleared because we got some, I think we got some interference, and it doesn't display anything at this moment. But if I restart right, it should display the values straight away in a second, right? So now you can see 1, 2, 3, 4, 5, 6, 7, 8. So make sure always that you supply the power to the display before you switch on the board, right? Because otherwise you may run into some issues. But I guess maybe if I was running the for loop with the set char method in the loop, probably that would have worked. But yeah, anyway, so now we've got this displayed. It's all good. And yeah, this is essentially how you supply the power. If you wanted to do it with the USB module instead of power supply, again, that's gonna be pretty straightforward. So what I'm gonna do is just disconnect this one. And here, you need to locate a 5 volts pin plus 5V. And then connect the wire, obviously, and then the ground, connect another wire, and on the breadboard itself, just connect the plus to 5V and minus to the ground, right? Because we have power supplied from the USB to the board, the 3V3. And so we just need another power line for 5 volts, and that's it. And I'm just gonna use the power bank to connect the USB there, so we can get the value displayed on the screen. But I need to restart again, like before. And as you can see, that works, right? Quite simple. Okay, so that's it for the basic functionality. However, if you want to see more, like for example, how to connect multiple screens, or how to display temperature and humidity read using DHT11 sensor, you're gonna have to wait until tomorrow for the next video. And if you don't want to miss that, I suggest hitting the subscribe button, so you will get notified as soon as I post that video. For today, this is it. Thank you very much for watching, and cheers, bye.